Okay, go ahead, Marek.
Do you see my presentation?
Yes.
The slide? Yeah, okay. So I'm here with a super quick overview of both our use cases. Michal did the resource resolution client and helped me with Artifact Manager, and yeah. Like from the high point of view, I want to just introduce what we are changing. We are adding two quote-unquote components into PyExecutor. First is Artifact Manager, and the second is Resource Resolution. They are separate Python packages that you can see here, and we also added a bunch of test configuration for testing with talks on multiple Python environments. And yeah, Artifact Manager is a separate package that you can install if you want separately. You can run it as a microservice just by itself, or include, and it's included by default right now into PyExecutor. So it will PyExecutor will handle the Artifact Manager gRPC methods. Yeah, we prepared detailed examples and how-tos that we will publish both in README files here or in wiki or read the docs. I'm not sure. I know it was subject of Tuesday discussions, so we'll talk about it later where to put it. But yeah, Artifact Manager you can run by itself, and Resource Resolution Client is a small package that you can import into your scripts, and very similarly as the previous resolution client, just call to resolve your needed templates, basically. We try to do it as user-friendly as possible, especially Resource Resolution Client. Michal prepared it with stability in mind. It auto-terminates connections, it cleans after itself if something goes wrong. You can use it, you can test it from terminal or use it in your script. And yeah, as I won't try to do into super deep details today, but as a second part, I want to do some walkthrough through the code. If you see my IDE, you probably do. You can see
yes,
that.
We can see it.
Okay. You can see that we basically kept to the same conventions as rest of PyExecutor. So configuration is in .ini files prepared here, both local and production. We kept with separate server serve file that can be run as like a standalone microservice, and basically outside of that, this at least Artifact Manager is a Python library that defines one gRPC servicer with that you can see here with a couple of methods, with just download blueprint, upload blueprint, and remove blueprint. All of the meat of the business logic basically is kept in util.spy when you can have a pluggable structure of basically blueprint repositories. You can implement, for example, we experimented with S3 based storage, but default what we're providing is file based storage that will handle all the zipping, unzipping, validating, and such here. But it's hopefully easy to modify if you have different needs, different places that you want to store your blueprints. A couple of custom errors were added by us as we talked with Brinda. For now, they all use 500 error before the proper error codes are defined, but it's super easy to change in future pull request. And one change with compared to existing approach we did is basically modify how we handle config files. They are now importable, so you can import the config instead of forwarding it through your code. You can import it from anywhere and use. Also in Artifact Manager, I added full MDC context for logs. So every required field from ONAP logging guidelines is included for every log. Every action generates a log of error or success. So we're ready to gather them, and based on them we can collect, for example, timings of or no, different useful things, I hope. Yeah, any questions about Artifact Manager?
Yeah, it's a perfect. Only thing is like how the configuration goes. It's like whether the configuration we want to put a single configuration from a container perspective, or we want to have a two different configurations to be deployed there.
I mean, yeah, there is environmental variable that you talked about, that basically says if we're on production or local. And we have separate configuration files, but they are only like specific to Artifact Manager. They're here inside. For example, the path to certificate files, or places where you like path to where to store blueprints. They're just specific to the Artifact Manager. The main configuration as you designed it is loaded based on this variable. So as long as we say it's development or it's production, everything should load automatically, and we can keep those up to date in repository or change locally before deployment.
So my question is slightly different. So with respect to environment, we are going to have one configuration file, or we are going to have multiple configuration, one for manager, one for Artifact Manager, and one for resource resolution, and one for gRPC processing. So whether we are going to have a 3 different configuration file with respect to environment, or we are going to have a single configuration file where we can put all these configuration, like artifact management configuration and resource resolution configuration and process configuration in a single file.
Okay, now I understand. So yeah, at this moment there are separate files.
Oh, okay. So is there any way to consolidate? Because I feel managing the 3 different configuration files slightly, it will be difficult, right? So in terms of passing the configuration and then location where we want to put that. You're getting my point? Or?
Yeah. I will look into could do it without
exactly.
any hacks.
That will be great.
Yeah.
Okay.
Yeah. Basically, the thing that we wanted to do previously was to use config maps from Kubernetes, but we ditched the idea because it was too time expensive and not consulted with you. But yeah.
Yeah, that's fine. That's fine. Yeah, okay, this I'm trying to.
Okay.
They say that where we are trying to. We need, because that will be easy for configuration perspective, configuration management perspective. That is the only point. And
okay.
One more thing. So I see that multiple packages, right? The artifact management. So is there any way, just I'm asking you, okay, in a Python base, we have a Maven, so where we can manage for Java related kind of stuffs, right? So where we can manage those components separately, and whenever I need that, just I input through Maven dependency. Okay. So similarly, think about like in this case, file executor is a common base microservice. Sometimes I may need an artifact manager. Sometimes I may not need an artifact manager. So in that case, can you give a solution or some thoughts like where we can take that artifact managers outside, and then suppose if there is any needed, then I can include through pip, okay, so that it can automatically download to be the part of the pip, so that I can develop that function similar to function. Say for an example, netconf monitoring. So tomorrow I want to develop a package called netconf monitoring. So in that case, I want to develop a package, and then I want to use it in a PyExecutor. Tomorrow I want to develop a package called a different functionality, or even certain different functionalities. Okay, so in that case, whenever I need, I can include it in a pip, so that automatically it includes that implementation inside that PyExecutor, so that it will be easy to manage what I really need with respect to that microservice creation, right?
Yeah, I think I get you. We went with the existing approach of requirements files, and because of the artifact manager is a package, it can be installed as any other requirement, and also it basically pulls in dependencies from the artifact manager.
Okay.
If we we can separate artifact manager as a like a separate Python package, not include inside PyExecutor, and then
okay, yeah, that is the point I'm trying to say. So we can have we have a microservice folder, right? So outside we have a scripting folder or packaging folder, or Python packages we can have, or Python modules we can have one more folder structure. There where we can build that artifact manager, or just copy there. Whenever I need, just I include it in a requirement, so that I can copy from that and then include it in my include it. Yeah.
No,
so in that way,
without issue. Yeah.
Exactly. In that case, people can develop separately. Okay, they don't want to come to PyExecutor, because PyExecutor, it's a common reference module. Okay, this is a reference microservice where showing some example to build that microservice. Okay, how we want to build that microservice, how we should interact with. Yeah, that's all I have. Yeah.
Okay. I will move this and treat it.
Yeah,
then
it's a very good.
It's no problem. Yeah.
And another question I have, it's like, did you see, or any chance whether we need optimization in that existing process? Okay, the dynamic module creations and accessing that CBA file, accessing the CBA script files, all those things. It's a perfect, or we need optimization there?
We didn't approach it yet.
Okay.
We wanted to like third part, which is creating a document about optimization and microservices in Python. We just moved this work there.
Exactly, because as far as I know, that Blueprint gRPC, the proto generations and all, it's like some way. I believe that it is like a hard coded, or it's not in a written in a right way. Okay, the proto generations. Okay, just that's the reason, because I'm not from Python background. Just I'm asking you how or what is the best way to generate the proto buffer. Okay, because each and every time I'm generating manually, it's like with the manual code, or executing the commands, and I'm generating and I'm copying that inside the proto. So is there any way there we can optimize the process of auto-generating the proto? Whenever I drop a proto file, automatically it generates a proto implementation for that, so that automatically it can include as a module. That's where I'm trying to think.
Okay. I'm not able to answer this at this moment, but I will do my best to cover this in this document. Okay, or give you the answer later. Right now, I need to research.
And microservice is coming up, right? So it's coming up, and then you don't have any issues in terms of accessing through microservices. Unit test cases, I'm fine. But with respect to microservice, it's any issues in there?
No.
Running inside the Docker container. Okay, yeah.
No, none. PyExecutor. I mean, it has all all the Docker files, as far as I remember, ready and working, and we didn't change anything there.
Okay, thank you. That's all I have. Thanks, Lord.
Brent, question regarding the PY executor. I don't think there's any charts yet, right, for Kubernetes?
Yeah, no.
It's only supported in Docker? So this is an action item.
Not it. It's because just I'm trying to introduce this experimental. Okay, so most probably Frankfurt, we can introduce that. We need that. If you want, we can track that as a separate Jira item for that.
Because for us, we're going to need it for sure for Frankfurt. And since we're using Kubernetes, then okay. I just wanted to.
Okay, so in that case, we can
to make sure it gets done. Okay.
Yeah. Because no, whatever I hear from the Bell, they are not going to deprecate from the command executor. That's the reason. No, I'm not concentrating a lot there. Okay, so now even CDS itself, it provides a lot of backward compatibility. Okay, with respect to the command executor, we are not touching. Yeah, we are not disturbing that any of the features. So that's what that is the reason. No, I didn't concentrate how far that you are involved.
Yeah, so that's okay for the remote, the old command executor, but I mean, all the point of having the resource resolution inside the PY executor is so that internally at Bell we can have people switch to the PY executor, but obviously we're going to need the PY executor to run in Kubernetes, otherwise, we're missing the point. So.
Right. Yeah, you're right.
Okay, thank you.
Okay, so then I will try to quickly go through the resource resolution client, which is basically one file and one big README that Michal prepared with examples how to connect, how to test, and basically it's a context manager in Python. So you open the connection like you would open a file. You call the process server, and you'll get the response. Yeah, without any configuration, any manual. It's literally one line to get connected, and it auto disconnects and auto cleans out after itself.
Okay, perfect. And along with that, it's a question to Sebastian itself. Sebastian, is it possible to move that CDS from base auth to TLS base auth? Because we want to follow a common pattern across all those configuration. Just I'm trying to look into that. Is there any way, or it's like a huge effort in converting the base auth to TLS auth? By executor already it has a TLS auth.
For the gRPC?
Yeah, for gRPC.
Okay, so yeah, I don't know. I'll have to check, because right now we are not using TLS, right?
Exactly, but I have already provided all implementation and samples. Everything is there. Okay, just only thing is we want to switch one thing that we want to test from SO. Okay, by using the TLS auth, because SO already integrated with the base auth. That's a one thing that we want to check. And internally we are using that from CDS to PyExecutor. We are using a TLS auth, and tomorrow if you are trying to bring a resource resolution component, so that can also be a TLS auth, so that PyExecutor can talk to the TLS auth. Okay, so that we don't want much configuration and managing user ID password throughout the place. So all should work.
So my take on this. So my take on this is that I think all of the OOM initiative with Service Mesh is to remove the need for internal ONAP component TLS, right?
Really?
So that internally everything is HTTP, because it runs inside a closed Kubernetes cluster, right? There's no, so what we want is that the Service Mesh will be the entry point. So this will be a TLS terminator, right? So
no, even the service mesh
ONAP
TLS, okay. Maybe your understanding may be slightly different, but what I'm trying to say, it's like the communication is a TLS, and then they want to get rid of user IDs and password. They want to use a certificate authority, and where they could manage the TLS by internally. So it means like we don't want to generate the TLS. Okay, certificate authority will generate the TLS and distribute that, and they can manage completely, so that we don't want to put or generate manually the TLS certificates and put it there. So it means like the service mesh will create that certificates and distribute the certificates through all the containers. Okay, so the concept, it's like using the TLS, it's a common everywhere. That is the only thing that we are going to use it. So everywhere TLS is going to.
Yeah, I'm not sure about that. I'm not sure.
Just verify that.
Okay,
yeah.
It's a different, it's a different discussion. But I mean, I think the problem with this is we need to manage the certificate, right?
Exactly.
So
that is the point I'm trying to say that.
Those can be.
That is the point I'm trying to say that. So they have a certificate authority internal. Okay, it comes with that. The certificate authority will manage and distribute the certificates to that all the containers. Okay, so that in that case, we are not going to manage it. So automatically that particular controller will manage that. But the underlying security is a TLS security. Okay, it is not a base or token base or any other thing. It's like a TLS base, but the how we are handling or how we are generating the certificates, it's a different. Okay, that it generates and automatically it distributes. Here we are generating manually and then we are having right now. But underlying, it is going to be TLS everywhere.
Okay. I think this probably implies that maybe if we use Kubernetes and we switch that, maybe Kubernetes can do the generation of the TLS automatically at some point.
Exactly.
Or something like that.
Exactly.
So yeah, I think it's I don't have an answer, but definitely we'll have to check.
Yeah, that is the thing. It's a TLS.
I don't know how much of a problem it would be.
So just look into that. Okay, I understand that whether we can use the TLS. So in that way, no, we don't want to manage user ID passwords. Okay, completely it can manage with TLS. Right now we can generate manually, and later even ONAP also they have the automatic generation of TLS. So we have a init component. So it automatically generates TLS and then distributes that both the server and client. So that no, we don't want to participate in that.
Okay. So if I understand correctly, we're gonna have to create the certificate for the TLS because we don't have service mesh yet, right?
Exactly, service mesh, and then we are not using ONAP init container. That is the reason.
Okay. All right. Okay, it's a good point. I think we'll have to look into it.
Yeah. Hey, thanks a lot. It's like I see a lot of information and then a lot of work happened there. So thanks a lot, team, for that. So really, it is coming up how I'm expecting that. Okay, and along with